A rectangular field is to be bounded by a fence on 3 sides and by a straight stream on the 4th side. Find the dimensions of the field with maximum area that can be enclosed using a 1,000 foot of fence. So here is a sketch of what's going on. We have a rectangular fence with only 2 sides the same, so y, and I'll call this side x. We know that the perimeter is 1,000 feet. So we need to pay attention to that the problem is asking us to find the maximum area. So that means we should begin by finding an area equation. Area of a rectangle is base times height, x times y. Now remember, normally we want a function of only one variable. So we're going to use the restriction of our perimeter to solve for y in terms of x. So our perimeter is 1,000, that equals 2y plus x. So y is 1,000 minus x divided by 2. Now I can create an area function in terms of x as x times 1,000 minus x over 2. I'm going to go ahead and simplify this a little bit more. That's going to be 500x minus 1/2 x squared, just a little easier to analyze. So now we need to look at the domain of this area function. Well, we know that x must be greater than or equal to 0 for the rectangle to exist. Y must be greater than or equal to 0. I know your natural instinct might be to say just greater than 0, but we actually do say greater than or equal to. Now remember, y was 1,000 minus x over 2 is greater than or equal to 0. If we solve this for x is less than or equal to 1,000. So the domain for our x values here are from 0 to 1,000. So now we need to figure out how to maximize this area. First thing we recognize is that a of x is a polynomial function, so it is continuous on this closed interval 0 to 1,000. So that means we can apply the extreme value theorem. The extreme value theorem states that the absolute max or min will happen either on the endpoints or at a critical value. So in order to find the critical values, we need to find our derivative of our area function, which is going to be 500 minus x. This equals 0 when x equals 500. So that is our critical value. So now we need to check our area function evaluated at our endpoints at our one critical value. So x and a of x, we're going to plug in our endpoints of our interval 0 and 1,000, and also our critical value of 500. So when we plug in 0 into a of x, we get 0. When we plug in 1,000 into a of x, we get 0. And if we plug 500 into a of x, we get 125,000. And so we can see that this is our maximum area. And that happens when x equals 0. So let's just double check what y equals because we need our dimensions. Y, when x is 500, is 1,000 minus 500 divided by 2, which is 250. So if we want to summarize what we've just discovered, we know that the field has a maximum area of 125,000 square feet with dimensions of 500 feet by 250 feet. So notice when you are showing this work on a free response exam, this table is required, finding your critical values is required, and figuring out your original function with its restrictions are required. If they ask for the dimensions, then you do need to add these two parts in.